Up, and now I should be live. Since there is no one in the stream, let's wait until I have audio feedback. Up. Okay, I have audio feedback. So let's continue. I started the teardown. Up. I'll show you. This is easier. I have two of these things. These are pulse light, intense pulse light, hair remover. I have two of them. I don't remember why I bought them. I wanted to see how they work and also test how it works. So the idea behind intense pulse light hair removal is that you have a really strong flash which burns away the black hair, and then you should have less hair. I don't know if it's really that efficient, if the hair never grows back, if it grows thinner. At least that's the promise they make. I don't know if they do it, but I have two which were already used, and I wanted to check how they work, and we will take them apart because I don't use them. I think it's too much effort. Shaving is a lot faster. So the first one is the Silken Home Skinovation, and I already started taking apart when I thought that it could be nice to taking apart on a stream. And how it looks like, we can even try to make it work again. Maybe the other one. Let's see. Up. So these are the parts. Yeah, this goes in the other way around in here. So generally you have a handle. Up. Put it the right way. This should be the handle. Maybe we can put it back together. Let's try if it works. Where was this? I think this was in here. Was it? No. This can't be in here. This was in here. Yeah, and I'll explain you why this was in here afterwards. For now, you'll just have to believe me that this was here. This was planted. This was connected here. Up. Plenty of electronics. Yeah, I don't remember how it is. What is this? This probably checks if something is in here, probably the button. I don't remember. These are just screws. Up. This goes down here. So yeah, after I'm taking it apart, I'm redoing it so I can take it further apart, but at least I can show you how it used to work. This probably goes here, and the electronic is stacked in a way. Since there's no button, but it has to find when this is pressed. Was there a button somewhere? Here. Here's the button. And there's probably no high voltage here. So let's try if it works. Up. Tack, tack, tack. Up, up. Power is on. Up. Power is on. The fan turns. I think you heard the noise. And the fan is loud, but it doesn't complain. And this is how strong the pulse is. It does complain. Why does it complain? It thinks that there is no... Yeah, I know why. It thinks that there is no electronic. Let's switch it off. I think the electronic board... Yes, this was the electronic board. It was connected here. Is this the right way around, or is it the other way? I think it doesn't make too much difference. Now let's see if it works. Yeah. Okay, that was the issue, and I know bit. Why? Does it detect when this is pressed? I think it does. Let's try. If I press the button, does it make a flash? No. And now, if I press the button and close my eyes, does it work? Okay. Do I have to press more? 100%. What do I have to do for it to work? Where is the sensor which we found? Was it here? Okay, so maybe something is missing. Probably this was a sensor. Switch it off so I don't get shocked, and let's check this thing again. Hup. Yeah, the sensor wasn't here. So the sensor detects, well, because it is intense light, I think it can be dangerous for the eye. The sensor detects when you press on this device here. There's a small tab which goes in between here. Hup, hup. So let's try it again. On. It doesn't complain with an arrow. Now I press up, and if I press on the button, no. Maybe 100% is that it is all completely used and not used anymore. Where is the manual? Is there a manual? Let me check. Oh yes. Also, apparently it only works on not too starkly, too dark skin or dark pigmentation, but actually it's just a really strong pulsed light generated by these light bulbs, and it should burn only the black of the hair. So if you have black skin, it might heat up your skin instead of the hair, so it wouldn't be that efficient. And I don't know if it could damage the skin. Probably. This is general purpose market. This is not a medical device. You can buy it on any store without having a kind of license or things like that. Okay, number 13. Yeah, 100%. So this means that this cartridge has been used at 100%, and this is why I got this unit for not a lot of money, because it was used, and this wouldn't be able to be used anymore. So I can't use this one to show you the flash it makes, but just believe me that it makes, let's switch it off. It just charges and then just makes a flash here. So let's continue taking it apart, remove the battery, and let's see all the elements in here. And how they make the money is probably not with the base station. I think it's the same as printers or razors, the business model. This they probably sell at a loss, but then the cartridges themselves, these things which you can change, they probably make a lot of money on these cartridges because they are consumables. I don't know. So they make money out of it. I don't know if they are really that less efficient. Well, after a certain point of time, if the bulb is used too often, I can see that this is less efficient. Because of chemistry and so on. I don't know if it's at the rate that they recommend. And if after you use it 100%, these bulbs really are not efficient anymore and wouldn't work anymore. I think they still do. Probably there would be some burn marks, so I don't know. I think they are still fine. They just try to sell you more, which is, it's a business. It's quite agreeable. But from a technical point of view, I think these bulbs, which are used 100%, look okay to me. So they could you could use them even if they're used more. Maybe they're less efficient, but they would be efficient enough. And how do they know when this is used or when this is not used? Let's focus a tiny bit more so you have a better view. How do they know when this is empty or not? Well, this is why I opened this, because do they measure? It's like with printer cartridges. How do they know that the printer cartridge is empty? Do they have a level meter which monitors the ink level? Not really. This is really hard to do. And on here, they probably don't measure how used the bulbs are using some kind of current or some kind of temperature or any kind of process. This is probably very hard to do. What they do is that just keep track how many times it has been fired. And this is why I open it, because here we just have an NFC tag or an NFC chip, or I don't know how secure it is, but this is just an NFC tag. You see the IC, the small computer in the middle, and then the antenna all around. And they keep track on how many times this has been fired on this chip. So when you get a new one, you get a new chip which says it has been fired 0 times. And after some point, well, this one they say it's been fired 100 times or 1,000 times. I don't know. I didn't use it, and it's written here, so we can't use it anymore because it's 100%. But they don't measure if the bulbs are still okay or not. They just have a counter, and this is in this chip. So if you can try to hack it actually. You just have to read out this chip, figure out if it's encrypted or not. I don't think so. I don't think they put a lot of security in it. You probably just can try to find what kind of data is read or what kind of data is written using man in the middle, or I don't know. And then rewrite the tag once you know where it is. I won't spend the effort because I'm not using the device, so I won't spend the effort on trying to hack it. The time I would spend on hacking it is probably more than the price of this. Could be still fun, and yeah, it is. It's like teardown. It could be a fun task. Afterwards, you still have, I think after some point it's less efficient and you would have to change the bulbs, but at least you could have it last a lot longer than what they needed. So this just holds the bulb and puts the contacts on it. And I don't know how these bulbs work. They seem like flash bulbs. Let's try to open them and see how they work. So they are in parallel. You have 2 bulbs in parallel. You see it because of the bar connection here. So one pin goes to this bar, which goes to one of the electrodes inside, and then this pin goes to the side, which is the filament, which is around the tubes. Maybe it needs it to start like a flash, and then these 2 are the electrodes on the other side individually. So we have 1 common ground and 2 probably voltage pulses, maybe at the same voltage. No, maybe not. I don't know. But that's it. And here we have the joint between the 2 filaments on this side. Can I take it more apart than just this? Yeah, there are screws. Let's unscrew it. Then we can have a better look at that. I will not use it. I just want to tear it down to see how it works. So I will not put it back together. Dun, dun, dun. So it's probably like a flash bulb. Yeah, it's probably a flash bulb with some characteristic lights. Maybe it's just a lot of white light, but they seem... Is it a filter? Yeah, it's a yellow filter. They filter out some lights. Which one it is? So if it's yellow, it means it passes everything. It passes only yellow. It blocks everything but yellow. So it only gets the yellow light. Ah, I think this is a UV filter. These lights probably have a broad spectrum, very broad spectrum, with plenty of UV, and the UV might be cancerous or damaging your skin, and probably this yellow light blocks UV. And maybe this gets also degraded over time because of the high impulse light. I don't know, it could be the case, but I'm not sure about it. Oh, you see even some tiny burn marks on there, so there is a lot of energy going through here. It is soldered after mounting because there is no way for me, because of the tab here, there's no way for me to remove it without breaking it. Let's try just to bend it. Okay, one glass tube is gone. And one pin is gone somewhere. Where is it? Ah, here. This one. And yeah, I can break the other one too. So there is also a piece of ceramic, or I don't know what it is. It's some kind of stone, maybe some ceramics. How can I disassemble this part? I have to press. Yeah. Ah, on the side also. So this is reflecting. These were here and on the side. This is very white, and this can probably take a lot of energy or doesn't transfer a lot of heat, and it's some kind of heat insulation. But you see it. You see this kind of. It's not plastic. It's ceramic or kind of stone, probably to isolate from the heat and the light and the intense light, so the plastic doesn't burn like it did here and here. It protects the plastic. We can test if it's an UV filter actually. Okay, one side, the other side. These are the bulbs. Whatever gas was inside, which was emitting the strong light, it's gone. There is no gas anymore. Doesn't smell like anything. Not that I could smell any gas particularly. Up. And here we have, so on the side we again have this kind of stone, ceramic stone, to protect against heat, and they are white. These stones are white, so everything which is there is kind of reflected, so you have a better intensity, because the light, the bulbs, not like any LED, don't shine straight forward, they shine on all around, and you would like most of the energy to go outside to the skin. So you could put directional reflectors, parabolas, or things like that, or just a white piece and hope that some of it is reflected to the front window. And the white also makes that it doesn't capture too much heat. The heat is mostly reflected, or the light is mostly reflected and not converted into heat. So that's the assembly. Okay. That's the front assembly. Now let's check if this is UV protection. Just by, let me get some paper. I need some white paper. And I don't know how well it will work with the camera. So here we have some white paper. If I shine it with UV, this is a UV lamp with a UV filter which only lets 365 or 395 nanometer. And I expect that if I put it in front, yep, you see, it blocks almost everything. The blue or the UV light. I mean, UV is not something you see, but this shines normally with UV, and we see also it shines in the middle. You see it shining there, so it means it is absorbing something. It is not reflecting back. You see it shining through, and then you see also nothing on the paper. So I think this is UV glass, so you don't get cancer, and you protect the skin from UV radiations. And these bulbs shine in the UV, but not only. So they put a bit of protection. I don't know if this was out super fast. Maybe this is also a safety risk, and they say only flash 100 times before removing. We could also have an NFC reader and find out which tag it is. I'll check if my phone can find out what tag it is. I'll not show you my phone right now, but let me switch on NFC and try to read the tag. It doesn't read the tag, so it's probably not a classic. The phone don't read all tag. You have several NFC standards or RFID standards as you would like. No, the phone doesn't find it. Oh, it does. It did it. Oh, it was a camera. Yep. Read tag. No, it found nothing. Up. Actually, I think I've tried in the past to. Yeah, here it is. Is it replaced by? Yeah, apparently this is an STM SRI 4K chip. I probably already tried to read it. So if you don't figure out what this kind of chip is, on the opposite side, you need a reader to be able to read this NFC chip. And this is the reader because it was placed just next to it. So here we have the optocoupler to be sure that this is pressed against a surface, most of the time your skin, or at least they'd expect the skin. If it's not pressed, no flashlight, so you don't get blinded. We have two contacts, and we've seen on this holder, yeah, here, when you press there, you have bent metal. Right here you have bent metal, and the bent metal probably makes the contacts to these things. So not only you need to break the pads, you also probably need to press the two buttons. Does it press on it? Yeah, it seems to be on there. Then we have, what else do we have here? This form here, this looks like an NFC antenna with plenty of tags. Here we have also an NFC antenna with some marking. I don't know if this marking is relevant, but let's have a look at the chip on it. This chip is, and this is probably only to check if it's pressed and what the chip is. And this is an ST CR14P-1GE. Let's check if we find a data sheet about that. CR14P-1GE. ST, and I think this is probably the NFC. Yep, this is, oh, this is an old chip. There's no data sheet anymore, or there's no public data sheet. CR14, there is the data sheet. It's called just CR14. Yep, B. Okay, now I get it. Let me just get the data sheet. Let me show you the monitor. Full screen? Yep. We don't need to see the laptop. That's done. So here, CR14. That's from, we've seen the ST logo, and with NFC you have this ISO 14443. Then there's A and B, and I think the phones read mostly A. Everything which is B they don't read. Or this is if you use 13 megahertz, you have these huge ISO classes which are used most of the time. You can have other things at 30.56 megahertz. But one of these is very frequent. You also have RFID tags more than NFC, which are at 125 kilohertz. This is not the case here. And if we have a look at it, this is probably just a reader. Yeah, type control, anti-control, connection management, support 400 I2C. So here we have an NFC reader. We could reuse it to, yeah, I could salvage it as an NFC reader. We just have to figure out which pin is connected where. So we can keep the cable, but the cable probably is mostly for the optocoupler and yeah, the cable, the information for the pins and the optocoupler very probably just go directly outside, although I don't know. You have plenty of transistors in there. But I'll keep it as an NFC tag reader, this device. So let's keep it this way. Then we have, well, let's come up from here. This is the harness which comes here. Well, there are plenty of boards. Seriously, 5 boards just to fit this handle. Whoa, that's a lot. What does this board have? Here we have the button to press whenever we want on. Then we have an LM. We have an LM393. This is either op amp or comparator, I don't know. And then a 0L05. I don't know what this is. 0L05. I'm not good with my logic. 0L05. Sub 8. We don't need this anymore. Sub 8 package. Could be anything. But what could it be on this board? Oh, 8L05A. Sorry. L05A. Yeah, obviously. It's a 5-volt regulator. Positive voltage regulator. Yeah. 805L. Okay, yeah, this is a voltage regulator. So this board doesn't have the voltage regulator. This board uses this as voltage regulator. This one. So there's something more than 5 volt coming in here. It gets regulated to 5 volts and then is sent here. So this board requires 5 volts. I wonder if let's zoom a bit out. I wonder if they designed the board individually, the same manufacturer, yeah. Or if they bought it separately, just assembled it, but they have the same PB3 logo. So I think they designed everything themselves. The font is the same. The layout looks similar, I don't know, but the font is the same. And the markings are very similar. So I think they designed everything. What is this? A separate board just for this chip. This is very probably a temperature sensor. LM35D. What is LM35D? LM35D. Datasheet. Oh yeah, precision centigrade temperature sensor datasheet. Okay. 1C voltage. So this probably measures the temperature inside the handle to know if this gets too warm or not. I think I'll keep it as well as sensor. Is it an analog sensor or digital sensor? Analog temperature sensor. Okay. I forget to switch all the time back to the bench. Let's also make this smaller. Up. So here we have the temperature sensor to figure out if the handle is too warm. I'll keep it also salvaged. I will salvage the NFC reader, button, and some comparator and some, or is it comparator? LM. I'm not good with analog design. LM393, what is it? Dual comparator, differential comparator. I'm probably comparing some voltages for I don't know what. Here we have a motor, which is quite beefy and compact. This is to cool the handle, and probably the temperature sensor will try to turn this one on or off. 12 volt. So okay, We have 12 volt coming in because this requires 12 volt. I think the same 12 volts are regulated down to 5 volts using this voltage regulator. And now I get it. This comparator probably compares the analog reading from the temperature controller and switches on or off the temperature. And there is no logic, is there? No, there is no microcontroller in the handle. So here we have again an LM393. This is a comparator. This is just a board, and here there is a transistor. This is probably a transistor for the fan. Up on the back side, just a transistor. Here in front, you again have transistor. Wow, having these connectors and these cables must cost us a lot of money. Couldn't they have designed one single board to put along here? I would have guessed just put one single board along here, if you can, then just have some connections. You need to read the NFC on around here, so it's hard. But this must cost a lot of money, having plenty of boards with the connectors. It's not very cheap. And I will keep the cables. I mean, these are micro JST cables. They're good. So on here there's just a comparator, plenty of diodes, and this is probably just for this thing. Here we have a transistor, probably to switch on and off this thing. And this, here we have the voltage and currents for the lamp. And then this probably a high voltage transformer to ignite the lamps. I don't know. I don't know how these lamps are driven, but it looks to me like a transformer, but the color of the winding is different. It's like a pink. T2, yeah, transformer. The winding is weird. The color of the winding, I know near about anima wire, even for high voltages. That's, yeah. And then this goes to the amateur for the head. Yep. Let's remove it. Let's remove this. Then we have the base. Let's have a look at the base. We already have some things we can salvage. An FC reader and the temperature sensor. The rest is electronics trash. Now let's have a look at inside the base. This is where all the charging happens and probably all the discharge. So I don't know. Maybe this is just a high voltage to start the spark, and then the high current can let it shine. And this regulates how strong the shiny is. I don't know. Here you have some more information about the device. I think I don't see any screws on the bottom, so I think they are beneath the feet. Yes. I hope my screwdriver is long enough. And we'll compare with the other one. How does the other one do it? And see if it works. I've never used the other one yet. Oh, open it. It was very dusty. Come on. Up, 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 up. Is it long enough? Yes. But not by long. See? All of this was inside. Model Silk N. Probably to have silky smooth skin. Made in Israel. Okay, I would have thought made in China. I didn't check when it was made. Yeah, Israel also. Home Silk Skin Innovation is probably a company. I don't know. Is it an FCC ID? I think there would be no, because there's no radiation. Oh, just FCC number. Oh, that's weird. We have 3 long screws and 1 short screw. Up. And there's no screw behind that. That's good. Okay. Okay. Can I unplug this? Here we have the main voltage coming in. Up. This is unplugged. Wow. Okay. That's not what I expected. Ah, okay. But so this is the AC input, filter capacity, common mode choke, full bridge rectifier, transformer, probably 12 volt transformer. Oh, there are 2 transformers, and huge capacitors. One is 330 volts, and we have 3 of them. So these lamps work with a lot more than just 12 volts. This is probably the 12 volt transformer. This is the 200 volts transformer. We can try to figure out if it charges the capacitor. I have to... it says also high voltage, so there's a high voltage pin. Let's measure if there is some high voltage. Let me switch on the multimeter so you can see what's happening. Multimeter on. So this is high voltage. We just need a ground. Here we have a 12 volt point. A tiny bit. Let's see if we have 12 volts still charging. Probably they have some discharge resistors, bleeding resistors. I don't know. Ground signal. This is here. So some ground signal. Yeah, there's no 12 volts. Is there some high voltage? No, they are discharging it. Let's try if we can make it charge with this open. Can I get this connector out? Else it's hard. It will complain that nothing is connected on the other side. Rightfully so. But will it do the charging? Let's check out. I want you to come out. Here. Isn't it this? Tab. Damn it. Maybe just this tab. Okay, 1. But yep, let's try the other side. It's well fitted. Okay. Now we have the AC connector out. We can plug the AC up. I will use my isolated transformer, so at least I don't get shocked too fast. Isolated transformer is on, battery is on, up. I'll get some gloves just to not get... I have no idea why OBS crashes. It didn't do that before. Does it still, audio still work? Yep, audio still works. I don't know. It's the second time it crashes. I have to check what's happening. But yeah, we have 12 volts, and actually I can make... now I know why I did this. We have 12 volts. That's done. Do we have high voltage? No. Does it report an error? It's not on. Now it's on, but it's reporting an error, so it doesn't charge anything. Okay, that's good design already, or at least a good start. Let's see if we connect everything back. if it does the charging. I have to find all the connections again. Ooh, I don't remember where everything was connected. There's so many cables. This was probably here. The motor was here. The motor, I don't think it has a sense wire. No, it wasn't here. The motor was here. Let me just unzoom so you can see my work. The motor was... Come on, go in. One way around. Yeah. Here we had the temperature sensor. This was here. They didn't mark the cables, but there's something missing. This goes definitely here. What is this connector for? Was it plugged? Do I miss something? Yep. Up. Is this off? Yeah, this is off. Let's turn this. Let's remove the plug. The connector was the input. This is the input right here, and I think they put everything on the same side. I didn't pay too much attention, and I would expect this connector to go here. No, it doesn't fit, so it goes on the other side. At least they did a good job that you can't fit the connector in the wrong place because they all have a different pin count. Good job. For now, I'm currently impressed by the quality of this. This goes here. Now we can try again. It will complain. Let's put the tag next to the NFC and let's glue it so it's happy. And maybe we can try the charge. A bit of tape. Okay. There's no lamp anymore. Well, we don't care about this. There will be no discharge, but I think, can it charge? Wheeze. If I don't connect ground, we will not have a reading. I hope this is the same ground. It might be a separate ground, but I think they have one ground. Okay, this is open. It still complains about something. What is it complaining about? The tag is not read the right way. I switched it off. Maybe the tag needs to be here so it can read it. Let's try again. On. Okay. Now it says 100%. I can't show you the lights, but it didn't charge. What a shame. It would be nice to have checked the charge, but because it's 100%, I cannot flash. So if I cannot flash, I cannot charge it. I don't want to hack it. I could... Okay, that it doesn't work. But we don't have any high voltage. We know it says this is at 330, so I would expect something like 200 volts, things like that. Let's continue the teardown, and we probably have no charge in here. Then we have also this 400 volts, but this is on the after the full bridge rectifier. I think this is to smooth that out. We'll have a look. Oh yeah, we see on this connector the small wires go to probably the MCU, and the large wires, the large wire which goes to the lamp afterwards, after the transformer, go to this side. And it's probably the same voltage, so let's remove this. But how does it know? Wait, there are only two wires. who this is saying charge it, please. We'll check out. For now, let's leave this in. Because we didn't measure any voltage. We didn't measure any voltage. It means that the capacitors are not, was it here? Yeah. The capacitor are not charged. The capacitor are not charged because this is not enabled. Who enables it and who measures it? So this is just the output going to the directly to the handle. Someone is telling it charge it or not. I think this is in this connection, which have really thick wire. So this is the 12 volts and probably the enable for charging this thing. Let's open this side. One. And let's see what's here. Until now, I wouldn't have expected so good design. I would have thought that this is, let me disconnect it. This is cheap. They even have a fan for cooling this electronic? No, I don't think this is for cooling the electronics. I think this is maybe to cool the handles or to cool this plate. The electronics here will never get heat up. Ah, I didn't check when it was produced. Was the date on the thing? Before 2010. The invoice was from 2010, so it's before 2010. We'll probably find some manufacturing dates on one of the chips. Why don't you... Is the screw hidden? No. Why can't you... Let's remove the fan for now. This is just a... And you can keep the fan. What is it? 12 volts, 120 ampere fan, 120 milliamperes fan. And 1, 2, plastic gets recycled. The fan will keep it. So you, why won't you come out? I don't think there are more screws. Maybe it's just... locked in. No, I don't see any screws anymore. There are screws, but this is not for the electronics. Yeah, it's just with tabs. So it needed a bit of force. There's probably one tab here. Yep. Here we have the electronics. What do I disconnect the handle? Let's disconnect the handle. Up. Up. Let's reconnect the handle because we want to try out. And where is this cable? This cable was going here. And this is probably a debugging port. Let's zoom in the electronics and let's have a closer look at the electronics. I can remove them, though the board has some buttons. So let's not remove it. I think it's only one-sided. Yeah, on the other side there are just some LEDs. And I don't see an electronic. Oh, there are some chips. What is this? Okay, we'll we'll open it afterwards. We can do it now. Let's do it now. We won't have the display, but the display is not too important. But what we can already see is a buzzer to complain, voltage regulator. This is probably again a 5-volt regulator, or here, no, this is the voltage regulator. So this is this transformer for this thing, because this is the 5-volt regulator. And here with the microcontroller checking everything. It says software assembly 101747A, software 101746A. Probably 10 stands for 2010, 17 the 17th week, and I want to check what kind of microcontroller it is. So we will have to remove the label. Let's put some alcohol and try. Where's the spatula? Where is the spatula? I want to remove the label. Oh, let's get another one. Up. So the glue. No, the glue didn't help a lot. The gloves don't allow me to pick it up. Do I need to put some heat on it just to get rid of the sticker? We have more than 4 connections, so it's not something like ICSP which just needs 2 connections plus and minus. And it's not JTAG because we need 4 connections plus and minus, and we have 5 here, so it's something in between. And we have a microchip, so it is ICSP. ICSP needs 3 pins. This is a PIC 16F886. Not sure if it has readout protection. Ah, isn't it the PIC interface? Let's have a look. I do have a programmer for that. Programmer. Ah, no, but it's not right. No, here 2, 5, 6. And this PIC kit has 6 pins. This has only 3 pins. 5 pins. One of them is probably not used. Not sure what it is. Ah, it needs 3. Okay, VPP. We could try to read it out to see if there's some read protection and some kind of checks, or to dump it, but not too important. But I was seeing a chip on the other side. What is this other chip? Probably some LED drivers. We'll have a look. So this is HCT244. What is this chip? Up. HCT244. How can I report this spam? Report and report. Okay. Oh, I wanted to check. Oh, we have 3 large buttons. So this is an HCT244. HCT444. It's a buffer. Okay. Octal buffer. Probably they use it as LED driver because the LED need more than what is this the chip is capable of using, and maybe for the buttons, but I would think it's but it's an octal buffer. And we have 1, 2, 3, 4, 5, plenty of LEDs. I don't know what this is for. Maybe you don't need always. Maybe they are Charlie-plexing the LEDs, so you don't need all the pins. I don't know. This did it go somewhere? So this went here. Let's try to enable. So this is the CPU which takes care of reading. We could actually, if we can read it out, we could actually patch that when it reads over this line. This is probably just directly I2C coming here, going to this NFC reader. This directly pros the I2C. So we could either fake the I2C with this cable or read out the the firmware here if we can read it out. Do I want to figure out how it is connected? Nah, no, I don't want to. I'm not fast. But if I would hack the thing, I would probably just look at the I2C lines and then change the data it read instead of reading the program here. But this would be another case. And here we have, this is probably 25PL03. What is this? 25PL03. No. And is there really an L, or is this just imagination? P03L. Really short-term memory. 03L. This is a MOSFET, a PMOS, 25 amps, 30 volts. Maybe this switches on and off the 12 volts for the board. I don't think so. Probably provides 12 volt in here. I don't know. We could trace out the traces. Where do the thick traces go? Yeah, they go here. They probably switch to 12 volts. Maybe not. Wait. Here is the button. The button probably switches on and off the 12 volts from here. Was there something here? Did I unplug something? The motor. The fan was here. We have test points also. Since we have test points, and since the tag is populated, I don't think there is a readout protection. We would have to guess, but we would have to check. But it seems like some engineering debug which is there. If they would be very security conscious, they wouldn't put the header on here and no test points right here, so probably don't care about that. Yep. So can we force, do we need the 12 volts here? We have several things up. Let me unzoom. We have these are probably optocouplers which switch on and off the voltage regulator. So this is dual-sided PCB, and on the other side we have the microcontroller for the coils. There is one MOSFET, large MOSFET here, but one MOSFET is not enough for both of them, is it? But I don't see any. Let's try to see what's on the bottom. 1, 2, and also I don't know. I probably will keep these capacitors. They haven't been used too much, but I won't keep the I won't keep the board. Here we have them. These are the chips for the wow. Okay, these spaces are huge. These are for the capacitors. I'm touching it without having proved it, but we measured it. There was nothing on high voltage. Let's check. No, there's nothing on there. Luckily I didn't put myself in danger. We have it, but this is, pads are huge, probably handling a lot of current and discharging really fast at I don't know how much voltage. Could be nice, although anything above 60 volts I don't want to keep, and I'm sure this is above 60. But what we see here there is a skid mark. It is a bit more brown. What is here? Fuses. Some resistors. And I think they measure the current. They have 10.3? No. 10E, sorry. 10E. I don't know what 10E. 10E means. Does 10E stands just for 10 ohm? What does resistor value 10E is? Resistor 10E. Ah, 10E, 100 ohms. So they have three 100 ohms resistor, probably in parallel. Yes, they are in parallel. So they want 33 ohms, and they're probably measuring, I don't know what they want to measure, but these resistors get super warm and toasty. The board is a bit marked, but this is, they're here for the 12 volt input. So they are feeding the 12 volts back in this thing to boost it instead of taking the 400 volts. No, I don't think that's possible. That would be wise. Here is the, so here's the full bridge rectifier. We have the DC, these are the two DC pins. Where is, one is probably ground, yeah, this is minus. This is ground, the other one goes here, which is the mauve, then here, then here, then here. No, it does go directly to this transformer. And we have three, we have separated this domain is separate to this domain. And nice labels. Good work. No, good work. I don't think I'll keep this board. This is just a transformer board. Could be nice for if you want 12. This is a really beefy 12 volt transformer though, because the 12 volt, there are only two motors for 12 volt, else there's nothing for 12 volts. Having such a beefy transformer just for 12 volts seems really ridiculous. Maybe I don't, do they feed 12 volts back in here to charge it up? Because it's already DC? That would be weird, but why not? And what is this doing? Why do we have only one MOSFET? Or is it a triac? Or oh, we have an NTC. Okay, we have, this is probably a Y capacitor for the isolation because it's switching transformer. Really good quality. I mean, you see how beefy the input, the common mode choke is. I think it's a common mode choke is, and everything huge. We could just keep it for 12 volts and then have a huge 12 volt transformer and probably plenty of current. No, don't know. The traces are not very, and the fronts, maybe in the front they are. This is 12 volts. Well, we have ground. Here it says plus, this is probably plus. And these two, here we have something which goes to this to this transistor, probably to switch on and off, and then we have something going around here. Then this is a limiting resistor, maybe just for the OK. But this is too high voltage. I won't play with it. I will keep this capacitors. I don't know what for. They seem fun. If you want something really high voltage, you could use this. I have no high voltage applications. Yeah, good build. So this is the first one. I think we'll stop with the taking apart the first one. I will salvage the NFC reader, the temperature sensor, and the capacitors. That's it. The transformers, I don't care. 12 volt transformer, I already have plenty of them. Common mode choke, I'm not doing any AC design. They even have 2 fuses. They have 1 ceramic fuse, good quality. Oh, good quality, at least not a glass fuse. And then 1 other fuse. It's probably a resistor, I don't know. It doesn't look like a resistor, the form. But they heat sink it. And huge input capacitors, good quality. Maybe I will keep also the full bridge rectifier that is useful, but common mode choke, meh. I don't use it and have other external ones. And that's it. So let's have a look at the other one, at the other IPL, and see the differences. Let's put things back here. For now, I will separate everything, and I will keep this switch. It's a huge latching switch. Up. That's for later. And this is everything here is trash. But I don't have plastic trash here. This is not plastic. I'll do it later. And I will keep this UV filter. Tack. Tack. Screws I don't need, at least not that long. I need only small screws, which are self-tappers. Up. Slim the bench a tiny bit. And this is the UV lamp. Let's have a look at the other one. The other one I didn't start to take it apart, so this will be also new for me. Up. So the other one is Silk N. They changed name. This is the crew made still for Silk N. It's probably newer. Does it have a date? By Silk N. Silk N. Okay, it's the same company. Let's see if the quality changed. And this is the model number 2014. It's a later model. I think every 2 years or 4 years they will change the model. But the cartridge gems are very similar. Let's have a look at them. Oh, let's try it out. I don't know if this one works. It doesn't like it. It made a weird noise. Okay. This is already bad design. I plugged it off, I hear a weird noise, and there is still something going on. No good start. Okay. This makes a rack. 10% remaining, and then 0% remaining. So we can test it and see how it works with this one. Oh, they changed it. It's not only... So they made some evolution. Before you just had to press, and I think if I press here, nothing happens. Yeah. Nothing happens. And if I press on it, nothing happens. But I think it wants some heat here. Let's try if I just put something in front. Does it work? Yes, it does. You probably saw the flash. And this is the minimum. You can increase the power, and it says when it's ready. At least this one works. There's not a lot left, 10%, but for working, for playing, it's enough. then it would say 0% when it's empty. But you see, the sensor is different here. It checks, and this is super noisy. And it checks. Why does it complain? Okay, we can have a look at this. There are some design changes. It's by the same people, so this is a good start. And when I turn it off, it doesn't switch off. Let's try to, okay. This at least discharges it. Do we start with the handle? Now you probably have also to buy these new things. Oh, yep, that's better design already, a newer design. And I would expect that here the still the NFC will, without breaking it, because it still works. Let's try to take this apart. No screws, so they are probably tabs. And here you could hack it, because I still have some values. If you want to hack it without having it working at the proper time and having a good setup, it's a bit harder. The design is probably very similar, but we can see the improvement. So this is for at least 2014. This one, the other one was a design from 2010. Okay. No. This is, I don't see where to open it. I don't feel the tabs. Is it welded? No, it's not. It's not welded, but wow. Stamp tabs. Is this a screw? Maybe I first need to open the other one. No, it's not. Because I don't hear it click anywhere. I did the complete one side. Whoop. There's no screw behind the sticker. Are there screws here? Not for the fan. Is this for a screw? I have the feeling that there's a screw here. But how would we remove this screw? I don't see any other entry point. Okay. Damn it. No idea how they clip it together. This is removed. Can I remove this thing? No. I don't want to brute force it because this is a working unit and I want to see it working and see the high voltages. I want to play with high voltages. Damn it. Okay. This is a challenge. Now is war. This is held together by the two parts. I really have the feeling that there's a screw. Oh. Ah, no. Okay. the tabs are. Do not close again. Probably there's one on top. There's one here. Not sure if it's a tab or a screw. Probably a screw. I'm struggling opening this device. It is really well assembled, and I can't figure out what mechanism is. And let's see if it's still a 4-part assembly or if they improved that. I'm destroying the plastic here, but I didn't intend to reuse it again. I still would like to be able to flash it while it's open. That's probably not the cleverest idea. Damn it, where is this thing going? Maybe I have to open the other side first and then remove the screws. Nope, same issue. Breaking everything. But I can't manage to open it. I really have the feeling that here there are screws. Did they break? Oh yes, I broke. There are screws. Yep. I broke this side. Let's break it even more. There are screws. I don't care anymore. Now, if there are screws, it means that there's a system to it. Ah, maybe. No, these are not screws. Is it welding? They don't want you to go inside, that's for sure. Ah! Are these screws? No. These are tabs. Wow. Not bad. It's, what kind of plastic is it? ABS plus PC. Phew. Okay, these are not screws, these are probably tabs. One-time tabs. Because you can't have access to the other side. This is the same principle on the other side. And yeah, they simplify the boards. They don't have 5 boards again, they have only 2 or 3. Now I have to break the other side. Ah. Not serviceable at all. This is probably easier to assemble because you don't need anyone screwing, but this is not serviceable. Everything is broken now. Okay, how do this thing work? Is it what kind of interlock is it? I'm curious about it. It doesn't even go completely out. No, it's held back by this plastic. Okay, I can't get it out completely. Not serviceable. Oh, let's get some cutters. 1, and 4. So here it plugs in and but it's not sliding, so it's not just a press fit. Do they weld it together? See, it's not turning at all. I have the feeling they are welding it inside this plastic from the one side, which goes on the plastic on the other side, doesn't move. If it's just a tab, it would still rotate, but it doesn't. So it seems to be either glue or welded. Probably glued, because for welding, vibrationist, and you see it's all around there is a rim for the case coming in, so it fits perfectly. This is a nice design, though it did good work, but not for repairability. Here, that's the same thing. Yeah, they probably put some glue inside. Let's try to cut it open and see what's inside. Yeah, I don't see any welding. Oh, it's far. Ah, here we have it. There is glue. So they put glue on the top and then they'll slide it in. But we have the same, okay, but also it's the same company. But we have the same design. Just on a different board. We have the power coming in. So this is probably very similar power. And the boards are interchangeable. The power coming in, you have the handle. You have this kind of transformer, probably I would say it's an ignition coil, but I don't really know. This is probably an infrared receiver transmitter. And do we have NFC again? But we have more electronics. Wow. Okay, these are the contacts. Can I move this? Up, up, up. The fan, I don't care about the fan. We'll just have one shots. Let's have a look. Okay. Wow. This is a PP diode. I don't know what for. Protection. Maybe it's a protection diode. This is probably a voltage regulator. Here we also have some optocoupler. Don't know what this is. It's small. It's not a PC 800 part. Here we see the NFC. And this is the same chip. So I think in here we have the same cartridge. Ah, we can test it. Do we have the other cartridge? Does it report an error? Let me get the NFC tag from the other one. No, where is it? Thought I put everything in here. So probably if you hack one, you hack all of them. I can't find it anymore. It would make sense to reuse the design. Damn it. I want to check if it's the same NFC tag. Ah, there it is. Still stuck. Because it's the same NFC reader. It's probably the same NFC tag. So, what if I put the tag here? Where's the antenna? So I have to peel off the tag, it doesn't fit inside. I had some tweezers, which here are tweezers. Now, if I put the tag here, will it work? I'm bending. Does it report 0% or does it report an error? We'll check. Okay, that's in. Let's try without tag to see what it reports. Okay, that should work. It does a self-test and then a standby. But the standby is squeezing. It's, I don't know if you can hear it. It is squeezing, which is not good. It starts. It never ends. Probably tries to read the chip. It will complain that there is no chip. Let's put the old chip right here and see if it says that it's at 0%. Okay, this was faster, but it didn't complain. I'm not sure if... Let's try it again. It's loud. Is it the same complaint then? No, it's not the same. You see, when there's no chip, it takes a lot longer. When there's this chip, the reaction is almost immediate. Yeah, it complains. It doesn't complain. Yeah, I know. It doesn't complain that it's at 0%. It complains that it is wrong. So they know the difference between the cartridges, but the chip is probably the same. Within this tag, it probably writes the cartridge is for this model and so on. And in here, there is a different model cartridge. I will not open it. Maybe if we have some time, we can try to hack it. And if this chip is not read protected, we can reread it. We can try actually read the data from this chip and put it on this chip if they are not protected chips. I don't know. That will be a task. And we can do it using the other NFC reader and just talking I2C. I mean, we might try this hack just for fun. And then we could try to read out this and see what happens. But this is noisy. Let's switch off. It is unplugged. Still turning, but this is unplugged. It has a huge charge. Okay, now this is emptied. Let's have a look at the board to see if what evolution there is. So let's remove the board again. So we have the same probably ignition coil. Oh, the intelligence is here now. Here we have a PIC 16. We can see it better. We have a PIC 16F690 here. Then we have the chip. So the handle is already doing some intelligence, while in the other one, everything was done in the base station, in the station. This is probably the... So here, I expect that there's no temperature sensor, is there? This is the voltage regulator, 78L05. This is a 5-volt regulator. And this is, I don't know, 75176B. But since they are turning the fan all the time, I think they don't have any temperature sensor anymore. I think. Else, why would they have the fan all the time if they know the temperature? This is for letting the energy into the bulb, like the other one, which can probably handle large pulses. Yeah, this is a high MOSFET probably for the large pulses. And here we have the distance sensor, and we see the NFC antenna again. Oh, software 101060. It's not too much younger. Same font, PB free. Same font, PB free. Here's the button to start. Plenty of other devices, and here. What is this sensor? I would like to have a look at it. Is it... I don't see any screws. Ah, tabs. Here, one tab and the other is on the other side. Ah. One tab and the other tab. Only two of them. Yeah. Oh, there's probably a temperature sensor. This break, this board. Let's see at the other side if we see something. There probably still some. Yes, there is. Here. Oh, wow. Oh, this is super advanced. I really didn't expect something like this. So here we have the temperature sensor. You see it's written RT1. Probably you don't see me because it's not zoomed enough. And I guessed it because there's a breakout which is going outside the board. So when you have a breakout, generally for kind of isolation, this is for the temperature isolation, and then you have the temperature sensor. But what I was really surprised about is this, which is in the detector. Which was, where's the detector? Here on this side. There is this detector which fits, on here. And what do? They have an LED, two LEDs shining through. Then it gets reflected by the object on top, reflected back in the middle, and there's probably some separation. Yeah, a tiny bit, not too much though. Maybe the light pipe is done so it only flows in this direction. That's possible. And then they read back the measurement with this color sensor. And you see the three colors, blue, red, blue, green. So they measure the skin pigmentation, and they probably don't let you if you have a too dark skin. We could try it with some paper. Let me assemble back. That's it. Just see it. Here we have the programming. And ICT1, this is to program the microcontroller on here. And this microcontroller, I know now they have the microcontroller also in the handle, because this takes care of the measurements right here, probably also of the temperature and the safety. And so let's put it back on, and let's see if with black paper or with a black surface it will not provide a a piece of light. This is my expectation. So it still needs this light sensor on the side. Let's put this back in. Tack, tack. Let's put this back. We'll try to keep it working, because we can make a small hacking session. Whoop. To figure out if we can make it work. If we can hack these thing and the values and see if it's protected. If they put some protection, they have some chips where you can, like here, this one, where you can just, when you write the bytes, they're fused forever. What you could do then is take a new one and write not to the byte which are burned. That's also a possibility. We'll check it out just for fun. And we'll see also the other side. But let's remove it and let's see if this dark sensor works. So, plug power in. We have to put, so this is the old tag. We'll probably try to reread it. These are the cartridges, consumables, same lamps. Also with the window, so no need to open it. I will take something black, not my phone, something we can take an energy, a silicon pad. Let's switch it on. Let's plug it, let's switch it on. Plug, switch on. It doesn't complain. It's super noisy. Let me remove the fan. This fan is far too noisy. We don't care about safety. Ah, better. And it doesn't complain. And now, if I press on the button, it should say that it shouldn't flash because the skin is very dark. Let's see if this is the case. That's not the case. I know what happened. What the fuck? Wow. Okay, so this is not a protection. I didn't expect this. Wow. It was a huge bang, and probably you saw the huge thing. So it's not to prevent dark pigmentation. It's to measure how strong pigmented you are. It did, yes. It did burn the this thing. So if it's really dark, the flash is a lot brighter, and I heard a lot brighter pop than the first time. Not bad. I don't want to completely use it. It's 10%, yeah, 10%. That's good enough because we want to try to hack it. There might be a small hacking session, a live hacking session, if you want to, where we can try to figure this out. But yes, so this is my guess was wrong. Well, not completely. This is not to detect if you have too dark skin and not be flashing, but if you have dark skin, then you flash a lot stronger. Okay, so let's disable it. Let's try to remove the power and let's open this thing. Up. We can actually, it's not completely broken. We can glue everything together like it was. It's not the same way, but we could glue everything together if we wanted to. Reuse it once it's hacked. So let's have a look at the inside here, and I would be interested to see how much, what's the voltage. I think there's lots of current, and the flash was really what made really a huge bang. Now it's made in Germany, but you know, okay, there's several brands on that. This is still, is it still the right in unit? There's no silk something, but yeah, they rebranded. Now it's Eno Essentials. Probably this is the German branding or the German branding for the same thing. Yeah, don't put it in water. Maybe. I expect. Oh, no screws here. There's only a screw in the middle here. No. There are no screws. Oh, don't tell me that they're welded. No screw. Do I feel something? This is just production mark. I don't feel any divots, so I don't think there's a screw beneath the label. Okay, they didn't want any screws anymore. We saw here, no screws. In the other one, there were plenty of screws. Here, there are no screws. They designed for manufacturability a lot. This I don't back if there's no screw here. No, there's no screw here. There's no screw here because it would make sense to put a screw here, but not here. So, is it welded or is it just tab locked? I don't want to completely destroy it. We want to hack it. Okay, we can remove the top. Maybe the screws are from the other side. And you first have to remove the top. Let's have a look at it. No. No. No, this is one mold. This is just a Nova mold plastic. But there are no screws in these holes. Let's try to find out if there are screws. I hope it's not welded or glued together. I mean, they glued already the handle, so why not glue this part? I hope also they discharge the capacitors. Yeah, it's glued. Damn it. the design here is probably very similar to the other design, with the huge capacitors and so on. It's just probably improved a tiny bit. Let me see. Yep. Is moving a tiny bit. Ah, these are just tabs. Or maybe I broke something, but it is a bit easier, and probably I broke also your eardrums. Ah, yep, just tabs, else it wouldn't fit back together. Oh no, it's not. Yeah, tabs. Let's break them. There's none here. Yeah, I think there's a tab here. Come on, break. It's bending my spudger. Repairability 0. Design is not bad, but 0 repairability. Yeah, same principle. They glued things in, which I broke now. Or the design, is it exactly the same? Let me. I didn't break everything. There's one part which I didn't. Now I broke it, like I broke your eardrums. Oh, it's exactly the same board, and it's probably exactly the same. No, maybe not. But the board is exactly the same. Let's have a look at the other one. You see? It's not exactly the same board. They made slight changes. But I would guess that they are compatible. I could just connect this one, it would work the same way. Here we have 2 capacitors. Here we only have 1 capacitor. But here there's a capacitor missing. And yeah, they would be compatible. The connectors are on the same side, the ground signal is all the same. They have slight changes. Yep, 2 capacitors. They would be compatible. Now, I don't think that this is the same, but we'll have a look at that. Here they put a bit of foam. I don't think it's for noise dampening because it's how loud it is on the other side. And you see here, they glued it in instead of screw or anything, and I had to break the tabs. This is very similar though. I don't expect too much change because, well, it worked. Wow. I don't think they put a lot of attention into security. We'll have a look. So Here is the start. Same microcontroller. PIC 16. See. PIC 16F887. This is same as the one on the other board. This was the old board. PIC 16867. I wouldn't be surprised that it's the same code. No, though it's not the same code. We don't have an octal buffer. We still have this huge MOSFET. What is this? LM903. I don't know what it is. Where is the voltage regulator? It's not on this side. We still have the buzzer to complain. We still have some lights. Don't know what this is. Is this the regulator? No, I don't think so. There are no capacitors next to it. Probably around here is the regulator. Here we have. This is to test. And here we have the. Why do we have two? I don't know what this is. So here we have the programming header 246. This is the programming header for this chip here because it's just next to it, and also because you see the pins I2C. Oh, switch. This is not a programming header. This is a debug header. Here we have the I2C clock and signal. This is probably to read out the NFC tag. So this still does the verification. The other one just checks the color and does the regulation on how much current is going. Here we have the switch. I think this is this switch. This switch here. I think this is this switch. And they probably map on this cable. Voltage ground, and then we have transceiver enable and RX. This is probably some. Whoa, this is weird. TX. This is enable. This is TX. This is RX. And there's probably some serial output. We don't have all of these things here. We have test points. Here we do have test points. Maybe it's the same here, but here it's clearly labeled, so we could tap on it and see. And we have also RS485. This is used for industrial communication. It's a bit more resilient than UART, but you could decode it using a simple RS485 chip, Max 485, things like that. Here we have a temperature probe, spare 2, spare 1, 2 spare pins, which they're not using probably. This is then the programming header. If this is not a programming header, 2, 4, 5, yeah, 5 connections. This is probably the programming header. But we can have a look at check. And now I want to see the voltage, which is on it. I hope there is no voltage right now. I didn't check before I touch it. Here is ground. Here, the high voltage was here. My multimeter can go up to 600 volts, yeah, 1000 volts. So this should be fine. This is connected. Let's connect power and let's be very cautious now because we have mains. On is this button. 7 volts? Not 7 volts. 670 volts. What? Let's switch it off and let's see if it bleeds out. It bleeds out very slowly. Okay, these capacitors are only rated for 330 volts. I didn't check it, but because we've measured 600 volts or something like that, they must be in series. Yes, they are. Let's leave this to the side. If I disconnect it, if I switch on, does it bleed faster? No, it doesn't. Ooh. Let's not touch it and let's wait until it bleeds out, because their capacitors are charged and are bleeding out very slowly, so don't touch inside. Maybe there's a reason why they didn't put screws on it. So yes, they are, you see it here, they are not put in parallel, they are put in series. So they have 1,000 microfarad, but in series, and thanks to putting in series, you have 990 volts max, and they are using 680 volts. Don't touch it. Dangerous. And it's still at 400 volts. I wouldn't touch the inside. Thankfully, the multimeter can go up to 1,000 volts because it did exceed the 600 volts. I didn't expect that the lamps would take that much voltage, and probably also the pulse is pretty high. Yeah, this goes to 600 volts. Does someone want a 600 volt voltage regulator? And we can check also what's happening now. So we could use this voltage regulator for 600 volts because we can tap on the signals and see which signal is high or not for charging. Now it's at 300 volts. Yeah, what you're seeing on the screen is accurate. It is still at 300 volts, but bleeding out. At least it's, I don't know where it bleeds. Did we see any bleeding resistors? I think these ones are probably bleeding. No, they aren't they? I don't know, because they are not very huge. I would have guessed one bleeding resistor across everything. I don't see anything. This is to charge. Probably here we have the diodes, so we are sure to charge them in the right order. These are I don't know. These are probably bleeding resistors, and they have put several of them in series to increase the voltage because they are small ones and we have 600 volts. So if you put them in line, you increase the voltage difference. 150, 150. Yeah, these are probably bleeding resistors. Would be my guess. Whew. Yeah, and I think this board is still fine. So that's it. We've did a look at it, and we will try to hack it, but that will be for another session. I don't have the time or the setup to hack it, but we'll just have a look and try to see if it is kind of protected or not. If it's not protected, we have a way to recharge and refill the things. We cannot test the things back. We can test it on this one. We could test it on the other one, but I don't care. It's complete. The other one is no, it's not. I could screw it back. I mean, the other one at least is screwable and is mountable. This one, I can glue it back. I cannot screw it back. So we could actually fix the other one and use the other one. And this goes here. But we'll try with this one to see if it works. But that's it. You've seen how this works. So we have 600 volts, plenty of amps. Going through the handle, we have a skin detection on the new one, which is not on the other one. And else, I think it's pretty much the same. And is it the same connector for the handle? No, it's not. Yeah, this one, the old one. This one is a bit larger. This one has a larger connector. And this is the right side. Yeah. So it's not completely the same connector on the header. It's the same connector on the base. Where are these screws coming from? From the top board. So there are some screws. Wow. Yeah. We do have screws here. Yeah, we do have screws here, and we have screws here. So we do have some screws. Probably the code here is very similar. They just respin it. We'll have a look, and we can try to. We can try to fake it. We could sniff. So we can do is we can sniff. I have to put some bit of tension. Let me check until it's. Let me leave it here to check when the high voltage is gone. Before I touch anything. Yeah, we still have anything about 50 volts is for me high voltage. We could tap the I2C communication. I think it does only I2C. We could trace it. But what I want to do is really read out the tags and rewrite the tags if we can. Hacking for another time. How long was the stream? 2 hours. That's okay. 2 hour stream. We will have another session for the hacks. But for now, this is it, and you see, and you know how Intel's pulse light correction works. Okay, enjoy. Bye bye.